Good morning, students. Today we are going to see the next topic of that line integral. So consider that the charge is moved from an initial position B to the final position A against the electric field E. Then the work done is given by. So this we have seen in the previous classes. So we are going to derive something about the line integral. Okay. So if I consider a charge moving from initial position B to final position A, so that I will take some position B here, some position A here. So if a point charge is moved in any direction like this from B to A, the work done is given by W is equal to minus Q, the integration between B to A, then at an electric field E dot dl. So this we have seen in the previous classes. So this is called the line integral, where E dot dl gives the component of E along the direction of dl. So the work done is given as W is equal to IQ minus Q integration B to A E dot dl. So the mathematical procedure involved in such a line integral is, first point is we need to choose an arbitrary length. Choose any arbitrary path B to A. B to A is the path. Then break up into smaller segments. It is break up into smaller segments. Okay. Next, third point is find the component E along each segments, then adding all the components, and multiply by charge. So this gives the total line integral. So hence we have the path from B to A. I will divide it into smaller segments, first, second, third, fourth and fifth. So I will call this as dl1 vector, this is dl2 vector, dl3, dl4, then this is dl5. Okay, so these are the smaller length segments. Then at each points we need to find the E component. So this is E1, then here it is E2, then here E3, then E4, then E5. So these are the E components. So what is the total work done we need to calculate? So it is nothing but W is equal to, charge remains the same, then we need to add all the components, that is E1 dot dl1 plus E2 dot dl2 plus goes on till E phi dot dl phi. So this is the line integral V8. So but the E component is uniform and equal in all directions. So therefore all E1 equal to E2 equal to till E phi, all will be equal to one E component. Then therefore work done is given as minus Q. I will take E component as outside, E multiply with the or dot product with all lengths, dl1 plus dl2 plus till dl phi. Okay, this is the work done. So we also can calculate the work done from B to A. If I take, this is B, here it is A point, the path chosen is like this. So we have divided this into smaller segments, that is dl1, dl2, dl3, dl4 and dl5. We have divided this. So we can also calculate in this way, or we can take the displacement value from B to A by joining B to A like this. So this is the displacement from B to A. So this length I will consider as L B to A. So the result is going to be same. So that work done W is given as minus Q into E component multiply with the length component L B to A. So the key point here is the work done depends on Q, E and L, B, A, and it does not depend on the path joining B to A. This is true for non-uniform electric field E as well. Okay. So the one more property is also true for this. This property is called as the conservative property of the electric field E, and field E is said to be conservative. Okay. So this is about the line integrals. So if you want to calculate the DL in different planes, so there may be Cartesian plane, cylindrical plane and spherical plane. So the differential length, the DL, varies depending on the planes which you choose. So if you choose the Cartesian, plane, the DL will be dx into ax plus dy into ay plus dz into az. So this will be the DL component. If you consider the cylindrical, plane, so the DL will vary as dr into ar plus, these all are the vectors, these all are vector components. So dr into ar, then r d phi into a phi plus dz into az. So this is for cylindrical. So if you go for spherical, the DL varies as DL equal to dr ar plus r d theta into a theta plus r sin theta d phi into a phi. So depending upon your planes, you need to choose the DL value. So this is about the line integral, and further we will see in the next classes. Thank you.